Now that we've talked about slope, let's actually look at equations of lines. We would now want to find the actual full equation to define the line. And we'll start with what's known as point-slope form. And for this form, we need two pieces of information, the slope, m, and a point on the line, x1, y1. Then the point-slope form of a line is given by y minus y1 is equal to mx minus x1. So let's look at a couple of examples of using this. So I know I have a line with slope 2/3 that passes through the point -2, -3. And as a reminder, here's the point-slope form for the line. So the left-hand side says y minus y1. So I would have y minus -3. The right-hand side, the first thing we need is the slope, which is 2/3, times x minus x1, so x minus -2. And I'm going to go ahead and simplify this a little bit. To get y plus 3 is equal to 2/3 times x plus 2. Now the next thing I want to do is actually graph this line. To start with, we know that the point -2, -3 is on here, so we can start by graphing that point. And then we're actually going to use the slope. So the slope is 2/3, which is rise over run. So we should rise 2 points and run 3. So we should go up 2 and over 3. And now we can actually connect these 2 points. So I did not do a great job there, but we do get the idea. The next thing I want to do is find the point-slope form of a line that passes through the points 1, -2, and 3, 2. In order to use point-slope form, what I really need is a point and the slope. Well, here I have 2 points, but I don't have the slope. However, we can find the slope given these 2 points. We need y2 minus y1, so 2 minus -2, over x2 minus x1, 3 minus 1. We can then start simplifying this. 2 minus -2 is 4, and 3 minus 1 is 2, which gives us that our slope is 2. So now I'm going to use this point right here and my new slope to find my point-slope form. It said y minus y1, so y minus -2 is equal to the slope, 2, times x minus x1, which is -1. So what if I would have picked my other point? What would have happened? So instead of picking that point, what if I picked this point here? This time I would have y minus 2 is equal to my slope 2 times x minus x1, which is 3. So these two equations look very, very different. However, I'm claiming that they're actually not. They do give the exact same equation for the line. So either one of these points is perfectly valid to pick. However, your answers are going to look very different depending on which number you pick. The next thing we want to look at is the slope-intercept form of lines. So with point-slope, we needed a point and the slope. With slope-intercept, we're going to need the slope and an intercept. We're actually going to need the slope m and the y-intercept, 0, b. Then the slope-intercept form is y equal to mx plus b. So this is going to be very helpful because anytime I have any line that's in the form y equal to, the number in front of x will be the slope, and the other number will be the y-intercept. So let's look at some examples of using this. So I have a line that has slope -1/2 and y-intercept 0, 4. Slope-intercept form said y equal to, and then it said mx, so the slope times x. So -1/2 x, and then plus b, plus the y-intercept, which in this case is 4. So I have the equation of the line -1/2 x plus 4. We previously looked at this example right here, and we had 2 equations that I claimed were the same. So let's see if we can actually get these in slope-intercept form. Let's start with the one on the left. So I'm going to start by simplifying out my parentheses. On the left, I'm going to change the double negative to a positive, and on the right, I'm going to distribute the 2 times x and then 2 times negative 1. I'm then going to subtract 2 from both sides, and that leaves me with the equation y equal to 2x minus 4. So this is a line with slope 2 and y-intercept negative 4. What about the one on the right? I start by distributing my parentheses, 2 times x and then 2 times negative 3 is negative 6. I'm then going to add 2 to both sides. And when I do, that gives me y equal to 2x minus 4. So even though these two equations looked very different when we started, we did show that it actually did work. So when I'm given 2 points, I can use either point in my point slope form and still get a valid answer. For our last thing with lines, let's look at horizontal and vertical lines. For horizontal lines, they have slope of 0. Since my slope is 0, I know that it's going to be of the form y plus 0x, y equal to 0x plus the y-intercept b, which then simplifies to just y equal to b. So this is the form of a horizontal line, y equal to some number. For vertical lines, our slope is undefined. And these are of the form x equal to a. The idea being if our line is vertical, it's not moving left or right any, so x is constant, the actual x coordinate will be constant. So let's look at an example. So I want to look at the graphs of x equal to 4 and y equal to negative 1. I'm going to start with y equal to negative 1. We know this has slope 0, so that means it's going to be a horizontal line. However, we can think of it another way too. We know that y is negative 1, so that happens right here at this point, as well as at this point, and this point, and this point, and over here, and we can start to see my horizontal line. For x equal to 4, it's of the form of a vertical line, but even if we don't know that, we should start to think is, when is x equal to 4? Well, it's equal to 4 here, and also up here, and also down here, and we can start to see the vertical line appear. So x equal to 4 would be a vertical line.